Hello, ECO311. Now we move on to a very interesting chapter, dummy variable regression models, where we are dealing with some categorical variables, explanatory variables, such as gender, race, area type, province. Okay, so let's look at the outline. Okay, the nature of dummy variables, then I will talk about the difference between ANOVA and Ancover. But for this module, the focus would be more on Ancover. And then I will talk about intercept dummy, slope dummy, and interaction dummy. And then finally, piecewise linear regression model, which also deals with the change of the slope from a particular point onwards. Remember from chapter 8, you learned the child test about the possible change of the slope parameter, the F test on the child test, but it relates to time series regressions. But then for this chapter, piecewise linear regression model, with regard to the possible change of the slope parameter, the focus will be on cross-sectional data regression. Okay, and then just to give you some basic ideas on the dummy variables, either 1 or 0. So 1 means yes, the person meets the requirement, and then 0 means no. So it is binary, either 1 or 0. And then usually the dummy variable is derived from categorical variable. So from the study guide, there is an example here. I think I can enlarge it. Okay, so let's say I've got 5 people. The first 3 are male, the last 2 are female. So this is clearly a categorical variable. We have 2 categories, male and female. And then when I create a male dummy, the first 3 people, they are really male, so they meet the yes requirement. This is why the male dummy value equals 1. And then for the last 2 females, they are not male. Therefore, the male dummy equals 0. Similarly, if you want to derive the female dummy, the first 3 individuals, A, B, and C, they are not female because they are men. So the female dummy value is 0. And then for the last 2, they are indeed female. So the female dummy equals 1. And then one thing I need to mention now is that when you run the regressions, you really want to include the gender, let's say gender dummy variables. You cannot include both male and female dummy. One must be left out as reference group. Then you might ask the next question, which dummy must be left out as reference group? The answer is, it doesn't matter. So maybe you run the regressions in these ways, marks explained by study hours, and then you include the male dummy. In other words, you leave out the female dummy as reference group. Alternatively, you can run the regression as marks explained by study hours, but this time you include the female dummy. In other words, you leave out the male dummy as reference group. So I repeat, it does not really matter which dummy is left out as the reference group or reference category. And then now I want you to see if you can understand how I derive the 4 ethnicity dummies. Let me pause for 30 seconds. Okay, and then similarly, let's say you decide that you have valid reason to include the ethnicity dummy variables, and then again you must leave out one as reference category. Again, it does not matter which one is left out. So I have 2 examples here. The first one, marks explained by study hours, African dummy, colored dummy, Indian dummy. In other words, you leave out the white dummy as a reference category. Alternatively, you can run the regression as marks explained by study hours, African dummy, Indian dummy, white dummy. In other words, in the second case, you leave out colored dummy as the reference group. It does not matter which one you leave out. And then you might ask the question, what if I include all 4 dummies? And then the answer is no, you will be unable to derive a regression output. The reason is you suffer the problem of perfect collinearity or perfect multicollinearity, which is exactly what chapter 10 is all about, which is about the exact linear relationships between explanatory variables. But more on that later, not now, when we move on to chapter 10. Okay. And then now Ancover, analysis of variance. For the ANOVA model, this is the definition. The dependent variable is a quantitative variable. You can see the marks here, but all the independent variables are dummy or qualitative variables. In other words, you would not see a continuous quantitative explanatory variable such as age, study hours, number of lectures attended. They won't feature. I repeat, so for Ancover model, all the explanatory variables are dummy variables. Then you might ask, what is the purpose of running this type of Ancover model? And then the main purpose is to derive the sample mean of Y for each subgroup. And then I think there is a question. So I'm going to do question 1 here. Okay, so this is the sample regression function. Marks head explained by 2 dummy variables, colored and white. I think I simplified this question. I just assume for this hypothetical country, there are only 3 popular ethnicity groups, blacks, colors, and white. And then you can make use of this regression to derive the sample mean of Y or the sample mean of marks for each group. So let's start with the first one. Why do I get 51.7632 for the black groups? The reason is, let me use the full information from the regression. If the person is a black student, then the color dummy will be 0, isn't it? So you will have 51.7632 minus 2.4520 times 0 plus 2.9505, and then the white dummy will be 0 for someone who is black. And this is why the Y sample mean of Y for the black students, EMR would be 51. And then similarly for the color student, here. This is the detailed explanation. In fact, you have to show this detailed explanation. Okay. Then the color dummy indeed equals 1 plus 2.9050. Then the white dummy is 0. That explains why you have 51.7632 minus 2.4520. So the sample mean of the EMR for the color students is actually lower compared with the blacks. Actually a failure on average, 49 point something. And then finally for the white students, minus 2.4520 for someone who is a white, coming from the white ethnicity group, then the color dummy is 0. But the white dummy equals 1. So at the end, you will get the answer of 54 point something. Then it means out of the 3 groups, the white students enjoy the highest mean EMR. Remember, it's only the mean, okay? We never know about the deviation or the variance. Highest mean for the white students, 54 point something, followed by black students at the second best performing group, 51 point something on average. And finally, for the color students, 49 point something on average. Okay, I hope you are happy with this question and the Ancover model. Okay, and then we can move on to the Ancover model. For the Ancover model, once again, the Y variable, the dependent variable is quantitative. Look at the marks variable. But then for the explanatory or independent variables, it would include some quantitative continuous variables such as second year mark explained by first year's mark. So ECO1 mark is clearly the normal quantitative variable, but then we have got 2 dummies, qualitative variables. So if you see a combination of the normal quantitative variables and then the qualitative dummy variables, we call this Ancover model. Okay, and then now I want to move on to the next part, which is about the difference between intercept dummy and slope dummy. Okay, so we can look at this example actually coming from your in-class exercise, actually. Example 1, intercept dummy. Okay, so this is my Ancover regression. Why do I know it is an Ancover? Because marks explained by study hours, the normal quantitative variable, and then the qualitative dummy variable, female. And then I even give you the parameters. So marks head equals 40 plus 10 times study hours plus 10 times female dummy. So this is my intercept dummy. The reason I call it the intercept dummy is this dummy would cause the constant to differ by gender. Okay, actually from this regression, you can see male is left out as reference category. So from this overall regression, I derived the regression for each gender. So for the male, the regression equation is marks head equals 40 plus 10 times study hours plus 10 times the female dummy should be 0 for someone who is a male. So this term falls away. This is why the male regression is actually marks head equals 40 plus 10 times study hours. And then if you can understand the first one, you should have no problem to understand the second one. For the female students, the regression equation is marks head equals, there is actually a head missing here, equals 40 plus 10 times study hours plus 10 times 1, because we're really dealing with females. So the female dummy, intercept dummy equals 1. So 10 plus 40 gives you 50. Do you now see the difference in the constant between the two genders? But the slope remains the same. Look at the 10 there. And then you can do a graphical sketch. You can see two parallel lines, but the female regression line is located above the male regression line because of the greater constant. Okay, so this is what intercept dummy is all about. Okay, I hope you are happy with this explanation. And then I want to move on with slope dummy. Okay, this is how a slope dummy would look like. Okay, oopsie. Okay, so look at this one. Again, it comes from the in-class exercise, slope dummy, example 1. So this is the regression, marks explained by study hours, the normal quantitative variable. And if you see the product between a quantitative variable and a dummy variable, this whole product, we call it the slope dummy. Study hours times female. This whole thing is called a slope dummy. And we count the product of the two as one explanatory variable. So if we go back to this regression, there are two explanatory variables. This is the first one, study hours, and this is the second one, the whole thing, the slope dummy. So keep that in mind. Despite there are two variables featuring here, the product of a quantitative variable and a dummy variable, it is counted as one explanatory variable, namely slope dummy. And then from this overall regression, I can derive the regression for each gender, starting with male. So Mark's head equals 42.5 plus 5.68 study hours plus 3.64 times study hours times this female dummy is 0 because the person is male, or the focus group is male. So this whole term falls away, then this is my regression equation for the male. And then for the female, this female dummy equals 1, then this term would become 3.64 study hours. Then you add 3.64 study hours to 5.68 study hours, then you have a steeper slope now. Compare the two, please. Do you see 9.32 study hours? But constant is the same for the two. This is why we call this the slope dummy, because it causes the slope parameter to be different, let's say by gender in this case. And then you are going to see the graphical sketch. They start with the same constant, 42.5, but it is steeper for the female. So if we interpret carefully, it means if the female student study 1 more hour, the increase of mark would be greater, 9.32. But if a male student studies 1 more hour, the increase of mark is smaller, only 5.68. Can you think of any possible reasons? Maybe when the female students study 1 more hour, they are really concentrating on the chapters or the course content. So they would enjoy a greater improvement in the marks. But maybe who knows if when the male students study 1 more hour, their mindset is preoccupied with something else. Maybe they think about the English Premier League, the Sony PlayStation game that they saved last night. Yeah, you never know. Okay. And then you might wonder, is it possible to include both intercept dummy and slope dummy? And the answer is yes. So this example again comes from the in-class exercises. So look at this example. Marks explained by study hours, the normal quantitative variable. Then you see the intercept dummy, female. And then the slope dummy, female times study hours. And then from this overall regression, I can derive the regression for each gender. You can see constant and slope are different in both genders. So let me stop for 30 seconds for you to go through the answers and then the graphical sketch. Okay, and this is the graphical sketch. You can see steeper slope, slightly steeper for the female. And then the interesting thing is the constant. It means if male does not study, it means study hour is 0. Then the regression predicts he's going to only get 25 marks. But if the female student does not study as well, somehow her marks, estimated mark will be a bit greater, 35. But although it actually still stands for failure. 24.93, 35.06, both stands for failure. Okay.